Go.
Hello, my dear students, and welcome to our next video help session. This one is over a few questions I prepared dealing with mole ratios, though you may not explicitly recognize you're dealing with them, and the concept of limiting reagent. Okay? And I'm sorry I got these questions from ancillaries associated with your textbook, and they actually asked the question in terms of the excess reagent. But it says, under the proper conditions, ammonia, NH3, and oxygen will react to form dinitrogen monoxide, nitrous oxide, also called laughing gas, and water. And it says, write a balanced equation for this reaction. Well, I've got two nitrogens here, so I should probably put a 2 there, because there's 2 nitrogen atoms in one of these and 2 in one of these. And that would give me 6 hydrogens or 3 of these. And that would give me 3 oxygens here and 1 here for a total of 4. So I think if I put a 2 here and a 2 here and what? A 1 here and a 3 here, I believe everything is balanced. 2 nitrogen atoms, 2 nitrogen atoms. 6 hydrogen atoms, 3 times 2 or 6 hydrogen atoms. 3 times 1 oxygen plus 1 more is 4 oxygens, and 2 times 2. So my coefficients for this balanced equation are 2, 2, 1, and 3. Okay, for this reaction for the oxidation or the reaction with oxygen of ammonia gas to form nitrogen dioxide and water. Now it says, determine which reagent is in excess. You know, it's 6 of one, half a dozen of another. Are we determining the limiting reagent? I say limiting reagent. I believe your book says limiting reactant. Probably more precise from a chemist standpoint. I'm a biochemist, so I tend to, say reagent fairly frequently as well. Substrate, limiting substrate, because things rarely happen under what we call saturating conditions in biology. But some things are saturating, like oxygen, frequently, hopefully. So now it says I have the following conditions: 24.6 grams of ammonia and 21.4 grams of oxygen. Step 1, balanced equation. Step 2, go through the mole. Convert to moles. So oxygen, O2, is 32 grams per mole, and ammonia is 1 nitrogen at 14.007 and 3 hydrogens at 1.008. That's 17.031 grams per mole. If you want to do the oxygen, you can say 31.998 instead of 32, but I think you'll see it's not going to be important for this assignment. So, quickly, 21.4 grams of oxygen times 1 mole per 32 grams, or you can do 31.998, and that's equal to 0.669 mole of O2. Or if you use the 31.98, you punch it into your calculator, it will say 0.6687917995. Up to you. So this one, for my ammonia, 1 mole of ammonia, I multiply it by 1. 1 mole of ammonia is equal to 17.031 grams of ammonia. This is an equality, 1 over 1, because these two values are equal. So basically what I'm doing is dividing 24.6 by 17.03, and that tells me I have 1.44 mole. So if I start with 21.4 grams of oxygen, I'm starting with 0.669 moles. Okay? If I start with 24.6 grams of ammonia, I'm starting with 1.44. And I need equal amounts. Okay, my mole ratio of ammonia to oxygen is 2 ammonias for every oxygen, or 1/1, or 1:1. However you want to say it, if I simplify it. So look, I need equal amounts of this. If I react this much oxygen with this much ammonia, I'm only going to react with 0.669 moles of ammonia. It's the ammonia that is in excess. Abbreviated XS, okay? So your answer is ammonia. Now on the test, I guess you can just guess or grab it, but on these, I'd like you to show your work. Prove that you did it. Follow along with me. For the next one, I have 3.8 moles of ammonia. I'm already in moles. Half as much work this time. 84.2 grams of oxygen times 1 mole per 32 grams, or 31.998 grams. And that comes out to be 2.63 moles. Mole of O2. So, 3.8 versus 2.63. I need a 1:1 ratio. Whichever one's present in the least is the limiting reagent. Oxygen is limiting. So once again, it's my ammonia that is in excess. Okay? There's more of this than this on a molar basis, because these coefficients don't deal with mass. Okay? My law of conservation of mass says the mass of the products equals the mass of the reactants. Products over here, reactants over here. But when I write my balance equation, these coefficients say 2 moles of ammonia react with 2 moles of oxygen to form 1 mole of laughing gas and 3 moles of water. The next one, they gave me molecules. Okay, I can still convert it to moles, because I know that 3.6 times 10 to the 24th molecules of ammonia, I can multiply this times 1 mole of ammonia has 1 Avogadro's number, or 6.02 times 10 to the 23rd molecules. Okay, and this 318 grams of oxygen, man, that's almost 10 moles of oxygen, right? Oh, 84. Where did I get the 318? Yeah, okay. Yeah. So, times 1 mole per 32, so I was looking at the wrong problem, is equal to almost 10, or 9.94 mole of O2. How many moles of ammonia is this? Okay, well, if I divide 3.6 times 10 to the 24th, that's a power of 10 bigger, but, this value is smaller, 3.6. And if I do the math, this is equal to 5.98 mole of NH3. I have 9.94 moles of O2, 5.98 moles of NH3. This is less because I need them on a 1:1 basis. So if I react these two quantities, only 5.98 moles of oxygen will react, which means it's the oxygen that is in excess. You could just circle it or whatever you want to do to indicate that that it is the reagent present in excess. And I'm sorry, that is the way the question was reacted. But if that one's in excess, the other one is limiting, okay? So when we talk about limiting reactant, sometimes we want to know which one's in excess. If I'm doing this reaction and I don't have very much of something, or something's expensive, or something's difficult to work with, and I don't want to have a great excess, it's like, wow, why are you using so much oxygen? Just use 5.98 moles instead of 9.94 moles, and you won't need to use up so much, or it won't cost so much, or you won't be exposed to so much. Those are important questions in modern society and in modern chemistry. Finally, on this one, and we're done with the first problem, it says 2.1 moles of ammonia. I'm already in moles, and 36.4 grams of oxygen, so times 1 mole of O2 per 32 grams of O2. It's going to be a little more than a mole. And if you do the math, it's 1.14 mole of O2 compared to 2.1 moles of ammonia, which I already gave you. This one is in excess. The ammonia is in excess. End of question 1. Go slow. Think of your mole ratios. Make sure you balance your equation. Convert everything to moles, and then just talk it out. Then you'll work these out. Okay. The second problem asks you, what about this reaction where I'm reacting zinc, a metal, with an acid? It always produces hydrogen gas, and a salt. In this case, my salt is zinc chloride. And if I balance this out, I see immediately that I have 2 chlorines here. So probably I'm going to want a 2 there. That would give me 1 H2 over here. And if I use 1 zinc, I have 2 chlorine atoms, 2 chlorine atoms, 2 hydrogen atoms, 2 hydrogen atoms, and 1 zinc atom. That is balanced. My coefficients are 1 to 2. 1, 2, 1, 1. But my molar ratios of zinc to hydrochloric acid is 1 zinc to 2 hydrochloric acid. Or you can do 1 zinc to 2 hydrochloric acid. 1 to 2. Okay? 1 to 2. Zinc to HCl, hydrochloric acid, hydrogen chloride. So, what happens if I start with these amounts? And that should be a Zn. There's no such element as Z. 12.5 grams of hydrochloric acid. Hydrochloric acid has a formula weight of 1 times 1.008 mass of hydrogen plus chlorine, 35.45. I just get those values, average atomic masses, right off of the periodic table, and I sum them up in the proportions that are present in the compound, which is 1 to 1, for a total of 36.458 grams per mole. Zinc, I just read its average atomic mass right off the periodic table. 1 mole of zinc weighs 65.38 grams. So, I convert everything to moles as I'm supposed to do. So 12.5 grams of HCl times 1 mole per 36.458. And that's equal to 0.343 mole. And for the zinc, it's a fairly light metal, but not that light. It's 7.3 times 1 mole per 65, or per 65.38. So 7.3 divided by that, and that gives me 0.111 mole. And for every one of these, I can react 2 of these. So times 2 would be 0.222 mole of zinc needed to react with that. So it's pretty clear that this is limiting because I only have 0.011 moles, and I would need 0.022 moles of hydrochloric acid. But they gave me 0.343, so it's in excess. That's my mole ratio. For every zinc I react, okay, I need 2 hydrochloric acids. But for every zinc here, I've got more than 2 hydrochloric acids. Here's 6.2 moles of HCl. Cool, it's already in moles. and 100 grams in zinc. I know that that is more than 1 mole of zinc because 1 mole weighs 65 grams and I have 100. So let me convert it. 100 grams of zinc times 1 mole per 65.38 grams. And that corresponds to 1.53 mole of zinc. Okay? Now, that will react with what? Times 2 would be 3.06 moles of hydrochloric acid, but they gave me 6.2. Sorry, I did not mean to call Siri up. It happens with my watch. If I just move my hand a certain way, I didn't realize I'd done it. So, going back, I have 1.53 moles of zinc. Okay? To react this much zinc, I would need twice that, or 3.06 mole of hydrochloric acid. But they gave me 6.2 moles. So this is in excess. Okay? The next one asks for 2.1 times 10 to the 23rd molecules of zinc and 26 grams of hydrochloric acid. Well, 26 grams of hydrochloric acid times, forget my hydrochloric acid is 36 times 1 mole per 36.458 grams. So, for this part D here, I have, when I do the math, in other words, divide 26 by 36.458, I have 0.713 mole of hydrochloric acid. And that can react with half that much, or 0.35, and what's half of 13? 6.5. 0.3565 or something moles of hydrochloric acid, but 363, whatever that would be, 0.713 divided by 2. We don't need that because we're going to convert our molecules. So this is times, and actually it says molecules of zinc. That really should say atoms of zinc, because we're talking about elemental zinc, and I'm talking about atoms. And they don't combine to form a diatomic molecule like iodine might, or oxygen or hydrogen might. So these are simply atoms times 1 mole of zinc per 1 Avogadro's number, 6.02 times 10 to the 23rd atoms of zinc. So I divide 2.1 by 6.02, and if you do that, I mean, you can go ahead and put the times 10 to the 23rd into your calculator, but if you're using a TI-84, make sure you put these in parentheses so you keep your order of operations proper. But since they both have, are raised to the same power, we can just 2.1 divided by 6.02, and that corresponds to 0.349 moles of zinc. Okay? And so, my hydrochloric acid, 2 of those, okay, one of these requires twice as much HCl. So times 2, I think I've done the math, I can do it in my head, 6, it's almost 3.5, so 6.698 mole of hydrochloric acid is required, and they gave us 0.713, so hydrochloric acid is in excess. Okay? This is what I'm doing. I'm converting everything to moles, and I'm using my mole ratio to see, do I have 1 zinc for every 2 hydrochloric acids? And if I have 1 to more than 2, then the hydrochloric acid is in excess. or if I have more than 1 to 2 in the final analysis, then my zinc is in excess. This one and now asks for 3.1 moles of zinc, so I'm going to need 6.2 moles of hydrochloric acid, and they're giving me 97 grams, 97.4 grams of hydrochloric acid. So if I multiply this times 1 mole of hydrochloric acid per 36.458 grams, excuse me, if I do the math and divide 97.4 by 36.458, I get 2.67 moles of HCl. And that is not double that. In fact, it's not even equal to 1 of that. So only half this many, or about 1.3335 moles of zinc will react, and they gave us 3.1. So this is clearly in excess. That is how you work these problems. And those were the answers to this assignment. I'm talking fast because people don't want to listen. Some people just want the answers. But if you really want to be a good chemist, if you really want to learn this material, play the tape back, play it slowly, do it a couple of times, follow along with the logic, have your work and paper out so you can do the calculations, and see while you're looking at this balanced equation why things are working out the way they are. I will try to post the next video help session, record it, get it recorded today or tomorrow and posted the next day, and get us going so we can move on to the next chapter. So until then, please stay safe and take care.